Ralph here once again, and it is the 27th of September 2020, and going to give you a different look at the data in reference to the ongoing hypothetical pandemic. Pandemic is a loose term. You're not going to find any solid definition to what a pandemic is. All it primarily means is an equal rise or a proportional rise globally of a certain type of ailment, disease, or other type of virus. Now, here we go. Before I begin, the problem with a lot of the case diagnosis is this. You're going to see a lot of people say cases to confirmed positives. If you look at the clinical criteria for cases, now I want to give that a few seconds. You may want to pause it, read through it. So basically what we're looking at here is a telehealth setting or outpatient. You're looking at a fever, measured or subjective, chills, rigors, myalgia, headache, sore throat, olfactory and taste disorders. So in a worst case scenario, what they have to have is at least two of the following symptoms. So if they don't feel well and their Fruit Loops taste weird, taste disorder, subjective, can be in a very unscrupulous way diagnosed as COVID. That's what it means by cases. Now, positive confirmation is a whole different ballgame, including to those post-mortem. Now, it goes through a little bit more here, and of course, no other alternative more likely diagnosis. But if you're rushed and you're having a hard time diagnosing people, and you got a little bit of bias in reference to COVID transmission, there's a higher likelihood, probably psychologically, of that bias causing an inflated case rate. Primarily the reason we saw this happen with pertussis or whooping cough, where it makes a lot of media sensation, and then if it gets reported more often, doesn't mean it's more prevalent in the community. It just means that we tend to look for it more often when it's the popular disease of the day. But now to begin. All right, so first, I ran this data ahead of time. All right, this is going to be you looking at data referenced from, this one is Oxford University. All right, so here we go. Beautiful data set from Oxford University. I'm just going to scroll down so you can see the information as we go through for those data analysts out there to make sure the data is legit. Moving through the heads, the columns that we drop. All right, now this is a little checkpoint I utilize here real fast. This is cases per million Sweden, cases per million US. Apples to apples. Even though the population density is a little less than Sweden, population density does not seem to be a correlating factor in regard to disease transmission, which is really bizarre to me. All right, so we run the data frame. There's total cases per million. Now this is as of 26th of September 2020. New cases per million. You see 41 there, 166 there. Let's make this a little bigger so you can see it for a second. All right, and then, whoa, that's real big. And then new deaths per million. That's of the 26th of September 2020. I have no clue why Sweden makes the news so often. Now keep in mind, they did very little in reference to lockdowns, and it's like almost this media baiting, waiting for them to fall. But guess what? Sweden is not, at least according to the data. All right, let's drop some columns there. I'm moving down the line. Boom, boom, boom. All right, ran some, yeah, that's Quintal Tau, but I dropped the columns so you can see a lot of numbers. Boom, 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 move a little faster. Moving to our world data. All right, this is the world. Now, the world we're looking at right now is the cumulative world data. This is new cases smooth per million, new deaths smooth per million. Here we go. Look at that. Now, normally you would think you'd have so many more cases. Now, remember, that was important. I showed you the case part ahead of time. So you get an idea the diagnosis is kind of loose and wild. But look at the new cases smooth per million, and look at the new deaths smooth per million. Now, normally you would expect more cases, more deaths. That is not how it's turning out. In April, that was a strong possibility, but right now, you probably have antigenic drift, and we're overkilling it. And you'll see why in a second on how we're actually probably causing more collateral damage from COVID-19 pandemic mitigation strategies than we are actually helping people. And we'll get to that in a second, all right? Let's move down the plots. This was your mortality rate, new death smooth, divided by new cases smooth. So that's our percentage. You could see we're either, the vulnerable populations either unfortunately are perishing or the disease is getting weaker, or our immune systems are getting stronger in defense to the disease. And there's other confounding factors outside that too. But you can see something's happening here. Now look right here. It's almost linear. Look at almost the algorithmic pattern, which I find extremely interesting between July and August. That could be a reporting issue too, but look at that. It's almost like you could do an XY slope. All right, now we're going to go down to a comparison between countries which had strict mitigation, pandemic mitigation strategies, lockdowns, so on and so forth, and those that did not. All right, so here we go. We're going to look at Sweden, Great Britain, England, USA, Singapore, Japan, Korea, and Taiwan. And Taiwan is just amazing to me. You'll see why in a second. Let us proceed. Boom, boom, boom. Change the date time. All right, and let's run so I can check this out at the very exact same time you are, because I just downloaded the data. All right, here goes the graph. And we are really close. We're back there just a little bit now. All right, there we are. All right, we have Great Britain lockdown. Where are we at Great Britain? All right, they are blue. Look at that. Now, this goes into the hypothesis of something called dysbiosis. Dysbiosis means that if you do a lockdown too long, that the social connections, the microbiome, the cultural immune system, so to say, begins to drop. So there were some interesting aspects from the American Society of Microbiology, which came out and found out that people which are social isolated too long actually became more susceptible to COVID-19. And I did that video last week, and you can review that on your own. But it's interesting. All right, now let's look at Japan, South Korea. Well, let's look at Japan. Right there, right along the x-axis. South Korea minor. Oh, sorry, not South Korea minor. South Korea minor lockdowns. I apologize. All right, going down this way. New cases per million, very low. Singapore is important. They'd had some pretty stringent lockdowns in the beginning, but however, though, the population density is high. And what we're doing here by looking at the population density, we're trying to see if that is a correlating factor in transmission of the disease. Now, this is why I'm doing the videos too. So you don't have to rely on multimedia, which doesn't understand data, presenting scary graphs. Look at that. Boom. I think they reopened up in June. And they determined in June that the lockdowns were superfluous. And that's probably the nicest word I can say. All right. Now, they did lock down certain ethnic groups, or migrant groups, I should say. But that's a whole different ballgame, and I'm not going to get into that political battle on that one. All right, Sweden. Now, Sweden is the bane of the European continent because they didn't listen to the fear-mongering. And fear is what it is, because what happened is this. There's a wonderful term that was from the American Academy of Advancement of Sciences that came out this last week. It's called weaponizing uncertainty, where they weaponize the possibility over probability. Where they'll say, well, if you don't wear your mask, if you don't walk to your right or walk to your left, that some individual, someone that you don't know, may die. And the possibility exists? Probably yes. Probability? No. But when you weaponize uncertainty, you're effectively making or creating superstition. And so remember that term, weaponizing uncertainty, and focus on that. If someone's not giving you a definitive or comparative, like these countries being controls, these countries right here, Sweden, Taiwan, and South Korea, and Japan, and Singapore, they should be our controls if we're running an experiment to see if what we're doing is right. Because if they are our controls, and this was an observational experiment, yeah, we will have problems. Our hypothesis or original guess looks to be very, very wrong, at least for the United States and Great Britain. Them using us as controls makes them proud because it made them seem like they made the right choice up to this point in time. All right, let's go to the next one. All right, we're going now to deaths per million smooth. I'm going to try to make this fast. I apologize. All right, here we go. New deaths per million smooth. But again, this is the data you don't get to see. All right, what are we looking at here? Great Britain, lockdown. All right. Now, this was initially, look how scary that must have been for them, even above the United States. But now as time goes on, I believe them, in my humble opinion, I believe the mitigation strategy that Great Britain is doing right now is horrible because I don't believe it's based upon sound observational science. Remember, a lot of the pandemic mitigation strategies that were incorporated were from studies or observations done decades ago. But however, though, a lot of the countries which seem to be succeeding are very, very mobile and adaptable to the current dynamics of the situation and seem to adjust pretty rapidly to whether something's working or not, and they don't become emotionally attached to the outcomes. Henceforth, again, weaponizing uncertainty just to scare people into what they think they're doing is right. But here we go. Japan, right there, deaths per million. Yeah, there it is. There's the title there. All right. South Korea, not minor, South Korea. Again, right there, along the x-axis. Singapore, along the x-axis. Sweden, yeah, you may have more cases, but look at the deaths per million. That should answer the question. Taiwan, I don't know what it is about Taiwan, but if I was an epidemiologist or control of the infectious disease, whatever country you're looking at, I would be sending scientists over to Taiwan in a very humble manner and figure out what the heck they did. Something that must have happened, whether they knew it or not, but I would be going through every bit of data they had to figure out how Taiwan and Hong Kong as well, which are not included in this axis yet, what they did to maintain this deaths per million along the x-axis, or virtually no deaths. All right, and then of course USA, still horrified of each other, social distancing, wrapping our heads with tons of towels, so on and so forth, because the United States, due to the political climate, we effectively, again, utilizing that term, weaponized uncertainty. But there's a tremendously devastating collateral damage to what we're doing in regard to the lockdowns, which we're about to approach. All right, let's run the code here. Again, All right, we're setting an index for those that don't know. All right, and here we go. Are you ready? All right, now this is the data frame, of course, right here, and this is total cases per million. United States, Sweden. Again, I showed you this the first time in the beginning, and this looks off. But as you begin to look, you go, whoa, Sweden's not doing too good. But again, it's how you present that data. I show you this chart, Sweden here, as opposed to this chart. That's pretty different. Japan, Korea, and again, whatever Taiwan does, they're miraculous. All right, now this is kind of the data that I utilize to make the next hypothetical approach in regard to the collateral damage caused by the COVID-19 lockdowns. Now, this has to be addressed, and I'm not seeing anybody produce any data analytics in reference to it, and they need to. The data I'm gathering here is from Johns Hopkins University in regard to speculation, in regard to hunger, starvation, so on and so forth. Are you ready? Here we go. And this is basically a very, very linear. We're just taking the data of the hypothesis, dividing it by the number of days of the pandemic, and drawing our conclusion from there. So the length of our data is over 271 days. Here we go. I don't want to be light about this because it's actually pretty serious because these are real lives. Even though that may not be included in what's called our monkey sphere. Monkey sphere is an old psychological term meaning that all because it happens far away, we can't relate to it. But however, though, we should, because it's really hurting a lot of the world. And here we go. What we're looking at here is, whoop, I can't even get into the thing. All right, let me back this up a little bit. This currently is the number of deaths from COVID. Horrible, no doubt about it. This is the excess deaths. The deaths beyond what would have normally have occurred in any other time or any other year. These are the combination just of two aspects. We're not talking suicides. We're not talking missed cancer diagnosis, heart disease, diabetes. I'm just taking two very, very important aspects. And there's a whole world of other things that we can add to this in regard to the collateral damage due to these lockdowns, which is almost criminal. Here we go. No, I apologize. It is criminal. Now, the starvation here, if you can read this here, for example, and this is important. This is the estimated, if you read here from Johns Hopkins, 2,300,000 additional child deaths due to collapse of the healthcare system and so on and so forth. Maternal deaths as well, I didn't even add into that. These are the excess deaths compared to the deaths of COVID and other common morbidities or complications of COVID or whatever. Very few cases we all know of actually just COVID itself. There usually has to be some of the combined aspects, and not belittling that. because that's important. Each life is important. But so are these. And these are the effects of basically our lockdowns are having on the rest of the world outside what we may call our monkey sphere. All right, now to speed it up, let's go to our COVID data focus for the United States. I don't like looking at those graphs. All right, so here goes our focus. Let's run it through. All right, this is we're getting a gets. So if you look at this for the data analysts out there, this is all current information. Let's give it a second. In fact, you know what? We're running, well, I have one thing in the back here. All right, run through the frames. Boom, boom. All right, this is, you notice there's no correlation between increases in hospitalizations, which I found really weird. We're going to find some real weird data here. And so just bear with me as whoops, I start running this stuff. Yeah, that's a neat little trick. Control Z brings it back. There's that. You're looking for correlations. I think this is, yeah, this is our pair plot. All right. Don't have to worry about that. Just get things running here. I'm just trying to find the data to make sure I don't make any errors. Don't need to run the head twice. Already got that in place. Let's run some of the correlations just because it's there. Let's run our first graph. Hospitalization increase to positive increases. This is the United States now we're looking at. All right, again, this is the data you don't get a chance to see. This is our hospitalization increases to a positive increase. Again, we looked at the world data prior to that. You see the dates there. And we're seeing a very similar pattern to the world data because the United States is primarily what's driving this. All right, now let's next one. Give you an idea. All right, run this. Now we're going to run our next figure, which you'll find very interesting. All right, this is the hospitalization increases to death increases over time. This is the most bizarre algorithmic pattern I've ever seen. I used to think, well, maybe it could be due to reporting errors and things like that. This, if you can explain this to me, I would love to hear it. Because look at this. And the weird part about it is as it continues, it's almost like, you know, a Monte Carlo simulation, or if you had like a bar chart and you're trying to form a bell or whatever it is. You know what I'm talking about, the people that are out there in statistics. All right, so we're here, it's like wild all across the board. It could be from data reporting. But then look at this. It's almost like, you know, you're painting a shadow over a line or a border around text, so to say. That is freaking bizarre. If anybody can explain that to me, I would love to hear how in the world this pattern is forming so incredibly parallel or shadowing each other. It's not even parallel. It's actually pretty much the exact same increases in deaths follow the exact same increase in hospitalizations. If I thought we were making advancements, what would you think would happen? You would think we'd have less death increases as hospitalization increases continue. But no, it's weird. All right, variance thing, I think it's going to end up being not a number. Boom. All right, let's run the next one. All right, let's proceed. I think this is, yeah, this is just within a short period of time. Look at our dates right there to September 25th or September 26th. Hospitalization increases, boom, down there to positive increases. That just gives you a brief snapshot. And here's our numbers from our data frame. All right, let's continue to run. And what is this one I just did? Let's see. That's a closer look at our data frame. Started September here to the date. Look at that shadow. I don't want to dwell on that too much, but look at that shadow. Because I don't have too much time to go through the whole thing. I don't want to bore you. That's amazing. Or confounding. So every time I look at it, I'm just trying to figure it out. All right, now next. Ready? Here we go. And we are going to go to a next frame here. That's going over the entire thing. Again, not to continue to run over it over and again, but I'm looking at it from different aspects. All right, now we're going to run a little bit of a time issue here. Ready? Here we go. And this is your hospitalization increase to death increase. Just for you to run through. You can see how the pattern forms. I'm just going to get these things moving along here as well, so I don't waste your time later on. And this is something about least squares. For those not familiar with statistics, it's a regression model. And that's just something I use for my own checkpoint. Look at that. That's insane. That is just, the pattern is just incredible. Normally, again, if you think you had a hospitalization increases, this should be bottoming out. But it actually follows each other and shadows itself pretty well. All right, now I'm going to go to this one and just get this one running real fast. And we'll let that one follow through. And so as that follows through, you can see exactly where it's going. But I'm going to show you too where to get the data from. This is an incredible, incredible, great data source. I'm going to link that as well. This is what I'm going to use for our stringency index when I go to make other judgment calls on other countries in regard to pandemic mitigation strategies working or not. And at the same time too, this is another great source right here from GitHub. That's your world data, just to give you an idea. Let's go back to this. All right. And we should, yep, we're done. All right, so we're running through the data frame there. This ran through. This is our basically of least squares. And yeah, this is kind of anticlimactic. This is again our hospital increase, the death increase. We do look like we have a solid correlation there, which is obvious because it's pretty darn solid if you look even at this graph visually. But again, this is Ralph signing off. If you want me to do this again next week, I shall. We'll start looking at other countries which have no limitations on movement to see exactly how they're fared. And also, too, since Florida pretty much ended the lockdown yesterday, it can be really interesting to see how things progress on an honest, subjective basis. So if Florida drops out of the news because they're doing well, you have a right to know. Again, Ralph signing off. Catch you all later on. And I know this was long, but again, gives different insight, and I want you to have access to the data too, so you don't have to trust what I say or anybody in the media says. Data is pretty cool. It's a little difficult to read in the beginning, but if you do, it'll enable you to have a lot of freedom, because truly, knowledge is freedom. And these days, it really, really is. Catch you all later on, and see you then. Bye.